Good morning, everybody. Hey. I see some people survived the reception last night. So, hi, I'm Bruce. I'd like to invite all the chairs up on the stage, the program chairs for the journal and conference. Yeah. Okay. Yeah. As you can see, we're quite organized. We'd like to just spend a little bit of time explaining the structure. And so first we'll talk a little bit about the journal track. Last year was the first year we split the reviewing between journal-only papers and conference papers, and we believe this has been quite successful in increasing the number of papers here at the conference, which then means the conference grows because people feel like they're part of the community. Okay, so there were 4 journal track, Greg Welsh, Kyle, Torsten, and myself, and we ranged across the world. Now we had 142 submissions. There was 600 authors. We had 33 accepted papers, new league record. This is the most journal papers we've had in the conference. We had 256 external reviewers who worked quite hard, and we would still like more reviewers to help us. We had so many papers, and then we had over 700 reviews, so there was a lot of work that was done. Okay, so a little bit about the process, because it is actually a journal. We wanted to have so the first process was a triage. We put all the papers into accept, and sadly some were a desk reject, and then discuss. And that was during an initial virtual PC meeting. And then during a second virtual PC meeting, we actually had a discussion. And during the discussion, so in the first round, the PC member would read the paper and then would have 3 external reviews. And in the second round, for the discussion, a second PC member would read the paper and potentially other external reviewers. And so the papers were thoroughly discussed during the meeting. After the conditionally accept paper, then they went into conditionally accept. There was a major revision, so there was 5 papers that were sent directly to TVCG. They weren't presented here, but they were fast-tracked through the TVCG review process, and then sadly there were some rejects. So after the conditional acceptance, it was 6 weeks, and this is where it's a journal paper that people were able to make modifications to the paper based and working with the PC member to have the paper accepted. So we attempted to have a shortened but real journal review process. And that was the thing. And I want to thank the chairs and for doing such a great job. So can we... So can we just get a picture of the chairs? Because I kind of like to have one on my wall. I'm pretty proud of these guys. Yeah, but I wasn't in the crowd. Okay.
Let's go for the second part. So for the conference track. So this year we were 6 program chairs in the conference track. So Joe Gabbard, Daniel Keff, Rob Tither, Anne-Hélène Olivier, Yuta Ito, and myself. So this was kind of also a record year for this, let's say, second edition of the conference track at BR. So we just got only 442 submissions with an acceptance rate of 21%. So this might look low, but we accepted 50% more papers than the previous year. And all this basically amount of work we're able to do it thanks to these 500 external reviewers and really let's let's say, considerable IPC committee of 77 members, splits all around the world, which resulted on almost more than 1,700 reviews, so a lot of text. So also this year we introduced 3 topic areas. So this was basically done for organizing purposes. So we were trying to parallelize as much as possible the review process. So we have 3 TAs, as I told you: technologies and applications, multisensory experiences, and interaction. I hope that you didn't struggle to choose which one to submit in PCS. Yes, it will get easier for the next years. And regarding the review process, so basically for all papers, the TA was let's say a suggestion for us to try to make the good distribution among the different TAs. So we were quite lucky, and all the submissions distributed almost equally around the 3 TAs. So that was kind of unexpected and extremely pleasing for us. And also similar with the IPC. So we recruited the IPC as a whole, but then we also split it in 3, trying to account for the preferences of the committee as much as possible. And then we have 3 independent review processes for each TA. So we have the review phase, a discussion phase, and a virtual IPC meeting for each TA. I would like to stress that we have no, let's say, acceptance limit for the TAs independently. So all the review process was done based on the quality. And then we gathered all the recommendations that were issued from the IPC meeting and were integrated in another meeting with all the 6 program chairs. And we basically classified the papers between conditional accept as a poster, and reject. And then we had a further shepherding process for the camera-ready version. And also I would like to thank also to all the chairs. And I think that we would like to make a real thanks to all the reviewers and all the program committee. And please, if you were in the process, please stand up.
So if you were a member of one of the 2 program committees, could you please stand up? Please stand up. And if you were one of the hundreds of reviewers, could you please stand up? It should be most of the room. Thank you very much.
So it's my great pleasure to present the IEEE Virtual Reality 2019 Best Paper Awards. So I am Ed Swan. The other members of this committee were Christian Sandor, City University of Hong Kong, and Sabine Kochia at INRIA. We had 2 tasks as a committee. The first was to determine the best journal paper and the best conference paper. The second was to archive the process and the results and document that for posterity. So based upon that, we wrote a message from the awards chairs. This message has been placed on the website. It should be going live right about now. And it has also been submitted to IEEE and will be archived permanently in the digital library as part of the messages from this conference. So first, I will present the best journal paper. So this began with the program chairs they examined the review scores, and based on the score distribution and a break in that distribution, they nominated 11 papers. These are the papers that were nominated. The committee wants to ensure that all of these nominees are recognized. So in addition to presenting them here, this list is archived in the committee report and again can be found upon the website and will be found in the digital library later. All of these papers are listed. As you have just seen, this year a historic number of papers have been submitted to all tracks. So just to be nominated indicates that the paper and the work reported is significant in terms of scope and quality. Given that this nomination process comes from reviewer scores, this is a distributed judgment from the larger technical community. So being nominated is an honorable event, and papers could be so marked upon vitas. So, the nominees for IEEE Virtual Reality 2019 Best Journal Paper are Shrinking Circles, Adaptation to Increased Curvature Gain and Redirected Walking. A perception-driven hybrid decomposition from multi-layer accommodative displays. Motion parallax for 360-degree RGBD video. Mega parallax, casual 360-degree panoramas with motion parallax. Developing virtual reality visualizations for unsteady flow analysis of dinosaur track formation using scientific sketching. Audiovisual olfactory resource allocation for trimodal virtual environments. Temporal resolution multiplexing, exploiting the limitations of spatiotemporal vision for more efficient VR rendering. Light attenuation display, subtractive see-through near-eye display via spatial color filtering. MoCap, real-time mobile 3D motion capture with a cap-mounted fisheye camera. Immersive telepresence and remote collaboration using mobile and wearable devices. Manufacturing application-driven foveated near-eye displays, the nominated papers. We had to come up with a selection process. Every year, the chair of this committee stands up here and discusses the difficulty of choosing a single paper to honor out of so much excellence. This year is no different. So we developed a ranking and scoring method where we read the papers and placed them in rank order. This was an extremely difficult exercise, but we did it. For each paper, for each reader, we then turned the ranks into scores. We used two different methods, one where we considered a complete 11-order rank, and another where we considered the top 5 papers ranked by each reader. We dealt with conflicts of interest by not reading or ranking those papers for whom a person was conflicted, of course. So some papers were conflicted with 2 readers. We decided at a minimum 2 people would read and rank each paper. Therefore, we recruited Doug Bowman, who helped us by reading and ranking a subset of the papers that were going to be competitive for the top award. Because of his help, every paper was ranked and read by at least 2 readers. We then came up with a weighting score that canceled the effect of different reader counts so that the final score for every paper was chosen from the same range of possible scores. The result of all this calculation was that 2 papers stood out from the rest, and one of those papers was ever so slightly higher than the other, but they were both very closely ranked. Therefore, we have a Best Journal Paper and a Best Journal Paper honorable mention. So the IEEE Virtual Reality 2019 Best Journal Paper is Temporal Resolution Multiplexing, Exploiting the Limitations of Spatio-Temporal Vision for More Efficient VR Rendering by George Danis, Kabu Marushtik, George Ash, and Raphael Matushik. The IEEE Virtual Reality 2019 Best Journal Paper Honorable Mention. MoCap, Real-Time Mobile 3D Motion Capture with a cap-mounted fisheye camera by Wei-Pin Kwa, Avishek Chekaji, Michael Solhofer, Helge Roden, Pascal Fuwa, Hans-Peter Seidel, and Christian Theobald. We also selected the IEEE Virtual Reality Best Conference Paper. Here, the conference paper program chairs nominated conference papers, again with the criteria of highest review scores. As you saw, there were 3 areas within which the reviewing was organized. The chairs nominated 4 papers in each area, so there were 12 papers nominated. And here they are. Again, I want to emphasize there was a historic number of papers submitted, and so being on this list is already a significant honor and could be so noted upon Vitas. So, the nominees for IEEE Virtual Reality 2019 Best Conference Paper are Remapped Physical Virtual Interfaces with Bimanual Haptic Retargeting, Jumping Further, Forward Jumps in a Gravity-Reduced Immersive Virtual Environment, Visual Manipulations for Underwater Drag Force Perception in Immersive Virtual Environments, Large-Scale Projection-Based Immersive Display, the Design and Implementation of Large Space, Multi-Ray Jumping, Comprehensible Group Navigation for Co-Located Users in Immersive Virtual Reality, IC through VR, Illuminating Cataracts through Virtual Reality, Immersive Spatial Audio Reproduction for VR AR using Room Acoustic Modeling from 360-degree images, Virtual Objects Look Farther on the Sides, the Anisotropy of Distance Perception in Virtual Reality, Estimating Detection Thresholds for Desktop Scale Hand Redirection in Virtual Reality, EEG can be used to measure embodiment when controlling a walking self-avatar. Virtual versus physical navigation in VR, study of gaze and body segment temporal reorientation behavior. Data Space, a reconfigurable hybrid reality environment for collaborative information analysis. The nominees. I should also mention all of these are listed in the message as well, of course. We used a similar selection process to what we did for the journals. We read the nominated papers, with great difficulty placed them in rank order, and then we turned those ranks into scores. Some papers were conflicted with one reader, so we met our criteria of 2 people reading every paper at a minimum, and therefore we did not recruit outside help for this decision. We again applied a correction to the calculated score to account for whether the paper had been read by 2 or 3 people, so that all scores were calculated from the same range of possible scores. The result of this calculation process is that one paper stood out, and therefore we have a best conference paper. So the IEEE Virtual Reality 2019 Best Conference Paper is Virtual Objects Look Farther on the Sides, the Anisotropy of Distance Perception in Virtual Reality by Etienne Pia, Thomas Thibault, Jean-Marie Norma, Ferran Agalagat-Sanz, Guillaume Moreau, and Anatole Lekia. Go ahead and hand that directly to one of them.
He does.
All right.
Okay, good morning. I'm Doug Bowman, and it's my pleasure to present the 2018 VGTC Virtual Reality Best Dissertation Award. I know we're running a little bit over time, so I'm going to try to make my part fast so we can spend time recognizing the winners. So the VR Best Dissertation Award is given each year to the author of the best doctoral dissertation in the broad field of virtual reality, and dissertations defended in the 2 previous calendar years are eligible. So it's a little bit confusing. Today is the 2018 award, and it's for dissertations that were defended in 2016 and 2017. So this is a long process before we get to the point of recognizing these dissertations. But we have this 2 calendar year rule because we want to give people at least 2 chances to win this award, since we have so many excellent dissertations in the field. So the process that we followed for this award is that we received nominations back in May of last year, And the nominations included a short 2-page summary of the significance of the dissertation, a letter of recommendation, typically from the student's advisor, a list of the publications resulting from the dissertation, and the full dissertation document. And we received 9 outstanding nominations, all of them really excellent pieces of work in our field. We had each nomination reviewed by 3 non-conflicted committee members, and I'll show the committee in just a second. And we rated, each of those reviewers rated the dissertations on a 3-point scale. Based on those ratings, which were all uniformly high, we did find that there were 2 dissertations that stood out from the rest in terms of score. We then went back, and everyone on the committee, except for conflicts, read both of those 2 top dissertations, and then we took a vote on the award. So here's the award committee, and if you all would please stand and be recognized as I call the names. So Ferran Aujalaguet, who's already been up here this morning, I was the chair, Jian Chen, Sabine Coquillard, Joaquim Jorge, Torsten Kuhlen, Rob Lindemann, Ed Swan, and Yasuyuki Yanagita. Could you all please stand? I want to say before I announce the 2018 award that we are already accepting nominations for the 2019 award that will be presented next year. The nominations are due on May 1st to myself, and there's my email address. More details about exactly what to submit will be coming out very soon on various email lists and the conference website. But please be thinking now about nominating the best work. We want to receive many more excellent nominations. Okay, so out of the top 2 dissertations that I mentioned, we identified an honorable mention and a winner. So the honorable mention for the 2018 VGTC IEEE Virtual Reality Best Dissertation Award goes to Richard Skarbez for his dissertation, Plausibility Illusion in Virtual Environments. He defended this dissertation at the University of North Carolina, Chapel Hill, and was advised by Mary Whitten and Fred Brooks. Rick? And for the Best Dissertation Award, we invite the winner to not only come and receive the award, but to give a short talk outlining the significance of the work. So without further ado, I'll announce that the winner of the 2018 VGTC Virtual Reality Best Dissertation Award is Sebastian Friston for his dissertation, Low Latency Rendering with Dataflow Architectures. He did this at University College London under the direction of Anthony Steed and Per Karlstrom. Sebastian. So Sebastian's going to give us some short remarks explaining the excellent work that he did.
Okay, thank you, and good morning. So my thesis was concerned with latency in VR, and it asked the question, how can we use Dataflow Computing to reduce latency in VR rendering, and how can we use this to better understand the effects of latency on human-computer interaction? So Dataflow Computing is an alternative computing architecture in which an algorithm is laid out in space rather than time. So unlike a traditional CPU, where you have a single piece of multifunctional silicon, which takes an operation, executes it, gets the other one, and continues this process operation by operation, in a data flow graph, each operation is given its own dedicated area of the chip. Designing for data flow computing is a little like designing for GPUs. Efficiency is maximized by minimizing divergence, but far more extreme. What they lack in flexibility, though, they make up for in performance, because data flow graphs have true parallelism of every operation. On every clock tick, you receive a new result, whether that result took 100 or 100,000 operations to compute. Once programmed, data flow graphs are implemented on data flow computers, built around devices with reconfigurable hardware, such as field-programmable data arrays. This project was conducted in collaboration with Maxella Technologies, who make data flow computers. This device on the left is a Maxella data flow engine, and it's effectively an FPGA card with very large amounts of memory and lots of I/O. The hardware, as you can see, occupies a similar location logically and physically in both the computer's architecture and the application's architecture as a traditional GPU. And this is pretty much how we used it. We reverse engineered some I/Os on this card to turn it into an image generator. And you want to do this because it's not just throughput you get from the data flow graph, but determinism. That one result per clock tick is not the best case scenario, it's always a scenario, which allows us to do things that we haven't been able to do in a while. Determinism allows us to generate pixels just in time and change the frame that we are scanning out during the scan out itself. Combined with a low persistence rolling shutter display like that in the OLED of the Oculus DK2, we can limit the amount of time that out-of-date pixels are visible to the user and overcome a key source of latency, that of the display scan out itself. So this video from this conference a few years ago shows a high-speed video at about 1,000 frames per second capturing the screen of the DK2, and that LED toggles to indicate a shifting camera pose. And as you can see, this combination of erasing the beam and low persistence display allows us to build a system for which the latency is no longer measured in milliseconds, but is measured in lines. So the challenges of data flow graphs put our renderer squarely in the reconstruction region of the rendering continuum. Over a series of iterations, we constructed a number of low-latency image generators, starting with simple 2D sprite renderers for low-level psychomotor tasks, up to our last variant, which was a hardware implementation of a raycaster. This could render very simple geometry with cutouts. Now, though we ran out of time eventually, the idea was always that we would continue to iterate on this middle section and would swap out the sampling functionality to move this image generator further and further along towards the extreme end of the image-based rendering continuum, taking full advantage of that huge amount of memory, 30 to 40 gigabytes on that DFE card. Now, unlike a traditional GPU, this device operates completely autonomously. So camera parameters are fed in asynchronously as fast as the host can generate them. As it's based on raycasting, the lens distortion map can be placed at the beginning of the graph, avoiding an expensive and synchronous warp at the end. So building this renderer is one thing, but to use it to investigate low latency, we needed to integrate it into a real VR system. So we outfitted our renderer with a protographics API, experimental control software, and some functionality to annotate the virtual world with some sprites, as well as a tracking system. And our tracking system was provided by fusing the IMU of the DK2, which runs at 1,000 hertz, along with our phase-space system, which runs at 960 hertz and has a latency of about 3 milliseconds. So the geometry of our raycaster was beyond simple, but with liberal use of texture mapping, I like to think anyway, we were able to achieve some quite convincing virtual worlds. I hope you will agree now they're blown up on this giant display. Take my word, they're very convincing on the laptop. That's our real lab down on the bottom where this was set up with its virtual counterpart on the top. There's no real counterpart for that virtual environment on the right. That was very important for the experiment. And my one regret is I don't have an image of the participant hooked up with the DK2 with the face-based LEDs on rods sticking out of it, all lit up, tracking all their joints. It was quite a sight. Altogether, we built a 4 by 6 meter room-scale virtual environment with one-to-one locomotion and an end-to-end position tracking latency of less than 4 milliseconds, a true latency before any predictive compensation. So we performed a number of experiments, both with and on this system. For example, we demonstrated the significance of this rendering approach to the fidelity of dynamic scenes using objective image quality measures. And we also performed user studies at both the high and low level, including walking short experiments and psychomotor tasks, or pointing and steering tasks. Some experiments showed very strong significance right away, others not so much. Some of the strongest came right at the start of the project. For example, it's typically hypothesized that the effects of latency are linear down to 0 as a consequence of the effects not following Weber's law. We showed that for at least some biophysical loops, this is not the case. This nonlinear plot has been made an appearance in a number of publications over the years, but it typically wasn't characterized in any detail. We saw it with enough reproducibility to attempt a characterization, and were able to do so almost down to 0. So that is a summary of what I hope are the most interesting, or at least photogenic, parts of my thesis. A primary goal of this project was always to build the lowest latency real working VE we could manage. This is very much an experimental apparatus, but it, like it from a number of groups over the last few years, has made it possible to really investigate low latencies with real VEs. And we should, because latency does not always remain predictable and can manifest in many different behaviors via many different mechanisms. But if I could leave you with just one thought, it would be to consider always the spatiotemporal characteristics of the display. Whether a constant scan out, or something like FreeSync or G-Sync, or an even more esoteric display, there will be a relationship between real-world time and the location on the display at which data is or is not visible. And by leveraging this, we can build systems with ever-decreasing latencies. And so I would just like to end by saying a big thank you to the committee for this award. Even in this exact area of novel rendering hardware at this conference, there are some really fantastic groups with some sort of excellent people, let alone across all the areas we see here every year. So I'm sure it was a very, very difficult decision, and I very much appreciate being selected this year. I'd like to thank all of you for being very welcoming, right from my very first conference before we even knew what this project was going to be. And finally, and especially to my supervisor, Professor Anthony Steed. Those of you who know Anthony will not be the slightest bit surprised to hear that he was a fantastic supervisor. And I consider myself very fortunate to have done my doctorate with him at his virtual environments group at UCL. Thank you.